I was on the Rust Discord page, and there was a question that said, is there a vector type that has a set length? For example, if it's 50 and I push another one, the last one gets removed and the new one gets inserted into the front. And somebody said you need a vecdeck to do this, and you might want to implement that on your own. So I did an implementation. I posted it to Discord, but I wanted to do it here in order to describe or to explain sort of my view on Rust and traits. So when I talk about traits, a lot of people say, well, that's just like C# interfaces, or it's a base class in C++. And it is kind of that, and it's hard to articulate it. So I want to describe traits this way. And this is not going to be the complete version of this, but traits do several things. It's a way to teach the compiler how to implement a behavior for a type. And I'll get into this a little bit more maybe in some other videos. It's also a way to communicate to the caller what a particular type should do. And it is also a way to bound the impact that a method will have on a value. And I'm actually going to do this implementation using traits, and it's going to seem a little backward, but I hope it makes sense when you see how this is put into practice. So I'm going to just implement this sort of as tests. So I'm going to have a test, and what do we usually have? It works. So I want to say I'm going to pull up my cheat sheet on the other monitor just so I don't lead you astray. So I'm going to create a queue, and I'm going to set this to be a vec deck of, I'm going to make these just I32s. It doesn't really matter what it is. And I'm going to give it a capacity of 5. That's going to be the bound of our queue here. And I'm going to call this method called test drop queue. And I'm going to give it a mute queue. And our fn test drop queue, the reason why I'm putting this in a separate function is I want to define the argument in terms of a trait, not in terms of a vecdeck. So this is going to take a mutable queue, which is of type, I'm going to call this drop queue. Drop queue of, it's an I32, right? So it doesn't know what drop queue is here. So let's define what that is. And let's move this out of the way to give it a little bit more real estate. And let's define what our drop queue is. So our drop queue is trait drop queue. And it's going to be of type T because it's going to store, it's going to push and pop elements of type T. So we need to have an fn insert, and it's going to take a mutable self because we need to modify who we are, and it's going to take a value of type T, and we're going to return a bool. And let's just say returns true if it had to remove an element from the queue. There we go. And really, this is what our drop queue looks like. And let's go ahead and import that there. So our test sort of works. Well, it works in the sense that we're not doing anything with it. Sorry. I was working in a different sort of system, so we'll pass it in like that. And drop queue is not implemented for this. Okay, so this is working here in our test. And actually, let's just do this. We're going to say, we're going to assert equals and q insert. And we're going to just insert a value. And we can insert this 5 times, and it should return false, right? This is not like, oh, we're just going to just plain assert. There we go. But on our 6th time, it's going to return true, indicating that it dropped the very last element. And we're using the capacity to define its overall bound. And we also need another one. We need a remove, and this is also going to be mutable self, and it's going to return an optional type T. So when I talk about traits as the way to teach the compiler how to implement a behavior for a type, this is what I mean. So we're going to impl drop Q of some type for vecdec of type T. And let's go ahead and have it implement the missing members. And right now, it compiles, but it fails because we don't have any. We have a to-do in here for the value. So our value here is, and actually I want to say this: teach vecdec how to behave like a drop queue. So our implementation is just going to say, well, if the length of our current self is equal to the self capacity, then we need to pop something. So self.pop front, self.push back, and we're going to push the value, and we're going to return true, right? And then else is going to be, we just self push back value, and we're going to return false. FRONT. There we go. And our tests actually now pass. They do what we expected to do. So this thing where we think of traits, or the implementation of our traits on a data type, is a way to say, okay, your trait behavior is like this. Here's a data structure. We're going to teach you how to behave like this trait. So rather than implementing our own type that is going to internally use a vecdec, we can use a vecdec directly. And in this case, we're using the capacity to store this. Now, we might actually want to, we might make this an option T here, which is going to maybe return some if it had to remove a value to insert the current value. This might be a better way to do this. Let return is going to be that, and we're going to return sum of return. Otherwise, we return none. This should be what we want, right? We can actually just return here. So let's just go ahead and finish this. So we'll change these to equals again, just so that our test is working right. So these should all, the first should return none, right? And this very last one should return sum of 1, right? And let's see if that passes our test. It does. So again, we can do remove here. This is just going to return self pop front, and I'm actually going to call this self remove because we can, well, let's go ahead and do this here. There we go. Good. So now everything works. We could do more tests of this. But the main thing I wanted to sort of pass on here is to come up with a way to better characterize what traits mean as a communication mechanism and a teaching method to teach the compiler new tricks. So that's my video here. Simple, short, sweet. What's nice about this is then you can implement, say, drop Q for different data types, which could also exhibit this behavior even if they have maybe different performance characteristics or other things like that.